I want to talk to you about the number E. E, as I promised. Remember that previously I said that if I have a natural log of, say, 5, that means log base E of 5. So the question was, what is this E? The E is a number, and the alphabet E itself is in honor of Swiss mathematician Leonhard Euler. Let me write it. I'm not sure if I'm pronouncing it correctly. Leonhard Euler. I know we write it, as Euler, but it's spelled Euler. Swiss mathematician that 1707 to 1783. And so this E in his name, we are calling that number E in his honor. Okay, so what is this number? The approximation of the number E is like 2.718 to 3 decimal. To 4 decimal would be 281, yes, 3, and on and on. I mean, the E is an irrational number, so there is no end to the digits. But how do we get this to be, how do we even get the approximation? So here is one way of looking at it. Since this course is in algebra, I'm going to show you how to look at this algebraically and not involving how we look at it using calculus. So we said that the future value of an investment is the present value 1 plus rate divided by n. That is how many times it's compounded to the power of nt. So let's say that you went and you somehow find a bank that is that can double your money, give you 100% interest on your money for 1 year. So then you're going to have, let me change the color. So you had $1. So your future value is going to be that $1 that you're investing in the beginning. 1 plus the rate is 100%. And remember, 100 divided by 100 is 1. So, and let's say that n is right here. First start with n as of like, it's been compounded only once a year to the power of n times t. So if you, let me put for n, let's put 1. And for time, of course, since we're talking about annual, t equals 1. So let me get rid of this one right here. So your dollar at the end of the year is going to be, this one here doesn't matter. 1 plus 1 over 1 is going to be 2, and 2 to the power of 1 equals 2. So you doubled your number. Now let's say that you somehow could manage to find another institution that this compounding was twice a year. So now you would have, let me actually go make a nice table and say when n equals 1, then you do have 1 plus 1 over n to the power of 1, and that gives you 2. When compounding is twice a year, so when n equals 2, then you get 1 plus 1 over 2 to the power of 2. And I put that in my calculator, 2.25. 1 plus 1/2 is 3/2. And if you score that, you get 9/4, which is 2.25. When n, let's say, equals 5, then you have, I'm going to put here this dot. So then you're going to have 1 plus 1 over 5 to the power of 5. And my calculator gave me 2.48832, which is more than 2.25. So our natural instinct tells us that as the number of n, as n is increasing, then this number will just go more and more and more and more, and you'll just make infinitely more money. But not so. Let's continue. So notice that when n equals 10, then I have 1 plus 1 over 10 to the power of 10. And according to my calculator, to 5 decimals, I got 2.59374, which is a higher number. But notice that the rate of increasing the answer is not as fast anymore. It's not increase. It's increasing, but not so much faster to compare with the first steps. The rate of increase is slowing down. That's what I'm trying to say. When n equals 1,000, then n equals 1,000, then I have 1 plus 1 over 1,000. Oops, too many zeros, sorry. To the power of 1,000, and my calculator gave me 2.7169 to 5 decimals. Let's do a couple more numbers so I can make my case. So let's say when n equals 1 million, 1 with 6 zeros, then I have 1 plus 1 over 1 million to the power of 1 million. And I got 2.71828, which is really, it's very slightly bigger than the previous number. And let's do one last number. When n equals 1 billion, 1 with 9 zeros, then I have 1 plus 1 over 1, 2, 3, 1, 2, 3, 1, 2, 3 to the power of 1 billion, 1, 2, 3, 1, 2, 3, 1, 2, 3. And notice that to 5 decimals, I get exactly the same number, 2.71828. So yes, if we continued the decimals, this number would be slightly more than the previous number, but nothing significant. So here's what happens in the language of, I was trying to stay away from calculus, but in the language of calculus, as n is getting larger and larger and larger, it tends to infinity, okay? As n is getting larger and larger and larger, it tends to infinity. Then 1 plus 1 over n to the power of n tends to the number e. So that's where that number e is coming from. There are other ways of explaining e, but it's not part of this course. And I hope this was a little bit helpful to you. Let me know if you have any questions. Thanks.